Hello everyone, I am Dr. Raman. In this section we are going to discuss with directional derivative problem. See the problem. Find the directional derivative of pi equal to x square yz plus 4xz square plus xyz at the point 1, 2, 3 in the direction of 2i vector plus j vector minus k vector. So first of all, what is the formula for directional derivative? So the directional derivative is nothing but directional derivative del pi dot a vector by a vector modulus. So this is a formula for calculating directional derivative. Now here in this problem given pi value, given pi equal to x square yz plus 4xz square plus xyz. Now first of all, to calculate gradient is nothing but del pi. Del pi equal to del value I vector dou by dou x, j vector dou by dou y, k vector dou by dou z. So this is the del value into pi value x square yz 4xz square xyz. Now multiply with every term. I vector dou by dou x of x square yz plus 4xz square plus xyz plus j vector dou by dou y of x square yz 4xz square plus xyz plus k vector dou by dou z of x square yz plus 4xz square plus xyz. Now derivative, partial derivative with respect to the first term x, where x here, here and here. Then j vector dou by dou y of y term, here y variable, dou by dou z of z term. Therefore here x, first term x only variable, other term to consider constant. I vector, when I differentiate x square 2x yz constant plus 4 into 1 z square plus x derivative 1 yz plus j vector, the first term x square constant, y differentiation 1 z plus 4 xz square. So no y term, therefore the whole term to consider constant 0. When the constant addition subtraction the value 0, product keep with the value as usual, plus x, y derivative 1 z plus k vector. So now dou by dou z of the term, when the consider z is the variable, other values are constant. Now x square y z derivative 1 plus 4x 2z plus xy into 1. Now the value is nothing but I vector 2xyz plus 4z square plus yz plus j vector x square z xz plus k vector x square y plus 8xz plus xy. So this is a del pi. Then at point 1, 2, 3, at point 1, 2, 3. Now substitute this value where in gradient pi, del pi at the point of 1, 2, 3. So here this is the x, y, z. Substitute where x1, y2, then z3. Therefore 2 into 1, 2, 3 plus 4 into z square 3 square plus y is 2 and z is 3 plus j vector x square 1 square z is 3 plus x value 1 z value 3 plus k vector x square 1 square 2 plus 8 into 1 into 3 plus xy is 1 into 2. Just substitute x value, y value, z value. Therefore, I vector 2 into 2 4 and 12 plus 9 into 4. So, 4 plus 3 square 9 36 plus 6. Then plus j vector 3 plus 3 plus k vector 2 plus 24 plus 2. Use calculator. Now 36 42 then 44 54 I vector plus 6 j vector plus 24 26 28 k vector. So this is a del pi at point 1 comma 2 comma 3. Now given the direction, so what is the direction? Given a vector, I vector, 2i vector plus j vector minus k vector. From this, a vector modulus means I vector coefficient plus j vector coefficient plus k vector coefficient, then square 2 square 1 square minus 1 square square root. Now 2 square 4 plus 1 plus 1 root 6 modulus of a vector. Now the directional derivative is nothing but directional derivative del pi dot a vector by a vector modulus. Therefore, del pi value 54 I vector plus 6 j vector plus 28 k vector. This is a del pi dot a vector I vector 2i vector plus j vector minus k vector by root 6. Therefore, now this is a dot product. When the dot product I vector dot I vector 1, j vector dot j vector 1, k vector dot k vector 1, other value when multiply the 0. So therefore this is a I dot I1. So 54 into 2 plus 6 into 1 plus 28 into minus 1 by root 6. Therefore this is a 108 plus 6 minus 28 by root 6. So therefore this is a 108 plus 6 minus 28. This is a 86 by root 6. This is our directional derivative. If you are using calculator, write in decimal. Is not a wrong. Thank you.